All right. So molecular compounds, unlike ionic compounds, remember ionic compounds are ions, so it's going to be a positive and a negative charge, or it's going to be a metal and a non-metal. Molecular compounds are two nonmetals. Chemically combined. They don't transfer electrons, they end up sharing electrons. All right, molecular compounds, they share electrons. From those shared electrons, they form covalent bonds. Covalent bonds are very strong chemical bonds. And their base units are called molecules. All right, so when we go to name molecular compounds, the formula is always going to be given to you. You just got to worry about naming the compound. So when you go to name the compound, we use prefixes. So naming molecular compounds, we use prefixes. And those prefixes are mono, stands for one. You're basically saying how many of each element you have or how many of each atom you have. Di stands for two. Tri stands for three. Tetra is four. And then we have penta equals 5. And then we get like in math. So hexa equals 6. Hepta is 7. Octa for 8. And then nona is 9. And deca is 10. You want one? Deca. That's the cake. You can't have cake.
He doesn't like Pokemon.
Which color? Name it. Red.
Are you a Pokemon? Yes, you are. You're not.
Here, come sit down. All right, so for example, when we are talking about molecular compounds, one that comes up a lot that you guys have heard of is CO2. So CO2. CO2 stands for carbon dioxide. And the way we name this, we first have to recognize that carbon's a nonmetal and oxygen's a nonmetal. So we have to say, okay, I have two nonmetals. And anytime I have two nonmetals, that means it's a molecular compound. So all I have to do is use the prefixes and then add IDE to the end.
Mommy,
Mm-hmm.
I get back.
All right, so carbon dioxide says that I have one carbon, but anytime the first element, there's only one of them, you do not use mono. So I'm just gonna put a star here that says, don't use mono for the first element. So we're not gonna use mono in the first element, but then when we get to the second element, we see, okay, oxygen has two, we say di for two, and then we're just still gonna use the add IDE to the end of the second element. So we say dioxide. So this is end of second element. So we're literally saying, using the prefix to say how many of each atom we have, and then we're still gonna add IDE to the end of the second element.
Oh.
All right, so for instance, like if CO, most of us have these detectors in our homes. We say carbon. And because there's only one of the first element, we don't use mono for the first element. So we're just gonna name carbon. And then the second element has one. So we say carbon monoxide. Most of us have carbon monoxide detectors in your home. I think you have to have it legally. And this is a gas, it's poisonous. So we have to have these type of detectors. That's ours. With the red on top. We don't have it. All right, so then let's go through some other examples. In this case, I have N2. So what's the prefix for two, guys? We would call N2 what?
Di.
Dinitrogen. So this would be dinitrogen. And then we look at F, it has 4. And so it's tetrafluoride. Fluoride, yeah. It was a formula. Okay. All right, then the next one. If we say, for instance, let's do P2O3. What do you guys think this is?
Phosphorus trioxide.
But how many phosphorus are there?
Yes,
Di. So
diphosphorus.
it's diphosphorus.
Exactly. Diphosphorus trichloride. That's the 2-year-old. He's trying to teach you guys.
Wow, he's smart.
All right, so let's pull up this other worksheet and let's work through these last couple on the other worksheet. So the next worksheet is, it's called Naming Molecular Compounds. Thank you.
If it's O3, why isn't it trioxide?
Because it should be, I don't know. I don't know what I was looking at, thank you.
Oh, okay, so it's trioxide, right?
It should be trioxide.
I like to break it.
All right,
Your mommy.
thank you. So now there's a worksheet under chapter 5. Okay, go get it. There's a worksheet on chapter 5, naming molecular compounds. Let's pull this one up and let's just do the first 12 on this page, and then that's it for today. So in this case, once again, I like these worksheets because it reminds you of how to do everything. It gives you examples. It tells you the rules of when you're naming molecular compounds. And then it gives you even the prefixes over here in the box in case you forget them. And so in this case, you're either going to have to write the name or write the formula.
Like the orange. Like the orange.
Okay,
Like the orange.
I will. Here, I got to put you down.
No.
Okay, guys, let's try to quickly go through these. So what do you guys think for the first one?
Sulfur dioxide.
Red.
Sulfur dioxide.
Oh, that's not red.
Mm-hmm.
I did what red?
Look, I did the orange. And then what about sulfur trioxide? What's its formula?
SO3.
SO3, right. And then what about number 3, guys?
Nitrogen.
Dinitrogen
I need
tetraoxide.
Remember,
Nitrogen tetraoxide.
yep, so dinitrogen tetraoxide, but in the case where you have 2 vials, you can just drop the A for the tetra. So you could just say tetroxide, and if you write tetraoxide, I'm fine with that too. Remember, for the first element, you still got to name it, name how many you have unless it's mono. So even if it's 2, you still got to say the 2. If it's only 1, you don't have to say you don't have to say mono. All right, number 4, what's its formula?
ClO2.
ClO2. Number 5,
Tetraphosphorus decaoxide.
tetraphosphorus, decoxide or decoxide, like that. And then carbon disulfide, CS2. Now this is nitrogen dioxide. Yeah, you see this one's a lot simpler than the ionic compounds. The only problem is you guys just get them mixed up. You have to recognize that you have a molecular compound versus an anionic compound. Dinitrogen, what's this? Tetrachloride. And then what about number 9? What's the formula?
XeF2.
All right, great. And this is disulfur dichloride. And then what's that? Cl3?
Yes.
And then diphosphorus pentasulfide. So make sense to you guys?
Yes.
Yeah, a lot simpler than the ionic compounds. So the ionic compounds are the ones you're gonna have to spend the most time on. Like I said, it doesn't get tricky, it's just you have to remember the rule. For the most part, you still gotta add IDE to the end of all of them, unless it has a polyatomic ion in it. But you have to remember, 1, to recognize the polyatomic ions for ionic compounds, and then 2, if you have a transition metal versus a group 1 or group 2 metal. So this is just the main point. These are molecular compounds. All of these elements and atoms are non-metals. So anytime you have a molecular compound, all you got to do is use the prefixes and add IDE to the end of the second element. And then if it has a metal in your compound, automatically assume it's an ionic compound. So just know if it has a metal like sodium, potassium, magnesium, calcium, all those metals, just automatically assume it's an ionic compound. Now, this is most of chapter 5 that we talked about today. I still have one other section to talk about, which is naming acids. So we'll talk about, I lied, it's 2 other sections. We have to talk about naming acids and then formula acids. But for the homework, you can do majority of the homework starting now. Most of the questions are just naming compounds, whether it's an ionic compound or a molecular compound. So I would go ahead and get started on the homework. It's about 40 questions. But make sure you guys get your homework done. I think most of you guys are doing well on the homework. It's an easy way to bring your grades up, and you always get 2 options so you can see what you do wrong and then email me or talk to me in class and see how to fix it. But with that said, that's all for today. Do I have any questions?
No.
Okay. So I will see you guys tomorrow. Remember, we're gonna finish up chapter 5 tomorrow and start chapter 6. And I'll see you guys tomorrow. Good luck. Talk to you later.
Okay, bye.
Bye.
Bye. Thank you.
Bye-bye. Thank you. Bye-bye, everyone.
Bye.